At the end of the previous lecture on equations, you were invited to try and solve this for yourself, and now we'll have a look at it. So what you should do here is, what you should identify is that you've got this division by a minus 2, and that makes things difficult. So you want to get rid of the difficulty. So what you want to do is undo dividing by 2, and to do that you must apply the inverse of dividing by 2, which is multiplying by, not 2, a minus 2. So I multiply both sides by a minus 2. Sorry about the baby crying, I can't control that. So if we multiply both sides by a minus 2, it'll get rid of this a minus 2. I get 2 is equal to 5 times a minus 2. Now, as an example of, there's not one specific series of tasks you can do. You can do whatever you want. So what I mean by that is you can multiply this out and then get rid of other things, but actually if you're trying to get a on its own and you're thinking in terms of the onion, the thing that's on the outside here is what you want to get rid of, is the 5. And what you do is you identify that as the function multiplied by 5. And so if you apply the inverse of multiplying by 5, which is dividing by 5, it'll get rid of it and you'll just be left with a minus 2. So I'm going to divide both sides by, now of course if you go at this a different way and get the right answer, that's no problem. So divide both sides by 5, I get 2 divided by 5 is equal to a minus 2. And then I want to get a on its own, but the minus 2 function has been applied, so I add 2 to both sides, because adding 2 is the inverse of subtracting 2. And if I add 2 to this, I'm fairly sure I get 12 over 5 using the calculator. So you might get it a slightly different way, but if you get the right answer, I'm happy enough. Okay, so we'll do, I think we just have two more examples, one for you to try, and that is that as far as equations. It's just this one principle. The difficulty might be little algebra things that I haven't done in depth, that might catch you a little bit, and the other issue would be just that you identify what the problem is. Okay, so here we're hoping to solve for r. Now what you should identify is that this divided by r is an issue. So you want to, basically all of the fractions you want to get rid of. So you want to get rid of that r. So the issue here is you've got to divide it by r. You've also got to divide it by r1. And you've also got to divide it by r2. And you want to get rid of all of them. So what you could do is apply the inverse of all of them. So you could do multiply both sides by r. That's a comma. Multiply by r1 and then multiply by r2. But it turns out if you multiply by, say if you multiply by 5 and then multiply by 6, that's the same as multiplying by 5 by 6 in one go, same as multiplying by 30. So we can do a similar story here. We can multiply by r times r1 times r2. And I'll be a little bit careful here, just showing what happens. You might have slightly different ways of doing this from school. By and large, if you're getting the answer right, I'm happy enough. Mathematically, this is probably a better way of doing it. So I'm going to multiply both sides. Now remember, now it turns out here that because it's a sum, you do multiply both of them separately, but I'm just going to show from what kind of laws of numbers does that follow. So let's multiply the left-hand side, and this time I'm actually going to write it, because normally I don't actually, I don't explicitly write the thing out like that. So that's that number multiplied by the left-hand side, and I also want that number to multiply the right-hand side. Okay, now what I'm going to use is this multiply out business. If you've a sum multiplied by something, you do this by this and this by this plus this by this. So I'm going to have r by r1 by r2 divided by r, and I'm going to be a little bit clever here. So the order of multiplication doesn't matter. So I can do, if I want, I can swap these two, and r by 1 over r, by 1 over r is r over r, which is equal to 1. And so you get r1 by r2 by 1, which is r1, r2. I'll just write a little note for that over here. So actually what actually happened there was I wrote these the other way around, and we got r1 times r2 times r times 1 over r, and r times 1 over r is equal to 1. So it's the same as like saying this is, so like x divided by x is x by 1 over x. And so x by 1 over x is 1, no matter what number you got. And 1 multiplied by any number gives you the same thing. So what I'm kind of saying is this thing is equal to 1. And R1, R2 times 1 is just R1, R2. Okay, that's how I would kind of think about that. And a similar story on the next one. I have R1 divided by R1, so they undo each other, and I'm just left with R2 equal to, similar story over here, R2 by 1 over R2, or just different ways of thinking about it. R2 divided by R2, so you can think of the dividing by R2 as the inverse of multiplying by R2, so you're just left with R times R1. Now you're hoping to solve for R, and the issue is you've got R's on both sides. So you're going to choose to get all the R's on the right hand side or left hand side, and I'm going to pick, for no particular reason, I'm going to pick the right hand side. So what I want to do now is I want to get this number out of there. So I don't want a plus or R2. So if I want to get rid of it, I apply the inverse function, and I'm a little stuck for space, so I'm going to do it here. So the inverse of plus that is minus that. And so I end up with R1, R2. So if I apply the minus R2, it gets rid of that. I'm just left with R1, R2. And on the right hand side, I apply that function as well. I have R1 minus R times R2. Now we're looking for R, and this is probably something, I don't know, will we have so much of this in the assessment, because factoring is something that we're kind of mostly leaving out, but you have a common factor here of R, which you can take out. So you end up, actually I'm going to do a little flip here. I'm nearly always ending up with the thing on the right hand side, which is a bit unnatural for us, but you can always swap. Now I'm not moving anything, like if you know, think of it, if 5 by 6 equals 30, 30 is equal to 5 by 6. Equals doesn't mean the answer is, it means the same, two things are the same, and if A is the same as B, then B is the same as A. So what I'm going to do is, this is going to be my new right hand side, and I'm going to take out the common factor there of R. And I'll be left with R1 minus R2 equals R1, R2. And now the thing was solved for R, it's multiplied by R1 minus R2. What is the inverse of multiplying by R1 minus R2 is dividing by R1 minus R2. So if I do that to the left hand side, it undoes the multiplication. I'm just left with R, which is what I'm looking for, and apply it to the right hand side, I get R1 R2 divided by R1 minus R2. If you get there a different way, that's fine, you can try it, as long as you're getting the right answer. But yeah, okay. Now the last one you can try and do yourself here as well. If you want to just pause the video and try it yourself, and then unpause it, and I'll do the question. So pause it now. Okay, now we're back. So again, what you want to say is you don't really like fractions. So you don't want this divided by A, you don't want this divided by B. They're things you want to get rid of. So you want to do the inverse of dividing by A and the inverse of dividing by B. You want to multiply by A and B, and multiplying by A and then multiplying by B is the same as multiplying by AB. Now we'll go a little bit faster this time. We won't do this line here. So if you multiply this sum by AB, if it's a sum, both of them get multiplied by AB. So if AB times 1 over A. Now what we'll do here is AB is the same as BA, order of multiplication doesn't matter. So we've got B times A times 1 over A, and A times 1 over A, you either say is 1, and 1 by B is B, or you say you have A divided by A, and the dividing by A undoes the multiplying, or you could even say that the other way around. But whatever you do here, AB times 1 over A, whatever way you think about it, numerous ways, this is just equal to B. You could also divide above and below by A, that would work as well. Similarly, if I do AB by this, I have A and B, so A is multiplied by B, and the division by B undoes the multiplying by B, so I'm just left with A is equal to 5AB. And we're asked to solve for A, so I'm going to choose to get all the A's on the right hand side. So I've got a plus A here, I don't want that there. What's the inverse of adding A, subtracting A? Do it to both sides, I get B is equal to 5AB minus A, and now I have a common factor of A, And again, I'm gonna flip the, not flip, I'm just gonna write them in the other order. Take out the common factor of a. What am I left with? 5b minus, and now the question is, what times a, or even what times minus a gives me minus a? Well, it's a times 1. So if you take out the common factor a, you're left with a 1 there, equal to b. And then finally, a is multiplied by this thing. To get rid of multiplying by that, you need to divide by that. So it's the same principle every time. I invite you to do exercises and submit them for feedback. There's plenty of exercises there. Okay.